Hello everyone, welcome to Neso Academy. In the previous lecture, we have understood the complete flow of machine learning pipeline. And from this lecture onwards, we are going to understand each of the steps of machine learning pipeline in more details, along with the practical implementations using Google Colab. So in this lecture, that is problem definition and data collection, we are going to understand the first two steps of machine learning pipeline, that are problem definition and data collection. So the topic for this lecture is also problem definition and data collection. Let's get started. This is the machine learning pipeline that we have discussed in the last lecture. To build a machine learning model, we first define the problem. After that, we collect the relevant data. After that, we perform basic data cleaning. After that, we split the data into two parts, training data and testing data. After splitting, we prepare the data. And after preparing the data, we select an appropriate machine learning algorithm. After that, we train the machine learning model. Then, we evaluate the performance of the machine learning model on unseen data. Finally, we save the machine learning model and we use the machine learning model to make predictions on new data. We also continuously monitor and improve the performance of our machine learning model over time. So this is the machine learning pipeline. And as I have just told you, in this lecture, we are going to focus only on the first two steps, problem definition and data collection. So let's start with problem definition. That is the step number 1. Problem definition is defining the objective before writing any code. What does that mean? It simply means before writing any machine learning code, or I can say before building the machine learning model, we must first define the objective of the machine learning model. What machine learning model needs to accomplish. So we must first clearly understand the problem statement that we are trying to solve. Because if the problem is not clear, then the whole machine learning process can go into wrong direction. Let's see the next point. Problem definition is defining the machine learning problem using the formal TPE framework. I have already explained you the TPE framework under the topic well-defined learning problem. T means task, P means performance measure, and E means experience. So while defining a problem statement, we need to identify the three components of that problem: task, performance measure, and experience. Task is the specific job that the machine learning model must do. What is the work of machine learning model? That is known as task. Performance measure is the metric, or I can say a measurement tool that is used to measure the success or performance of machine learning model on the given task. And what is experience? Experience is the data from which the machine learning model learns patterns, features, and relationships. So we need to identify these three components of our defined problem. For example, in case of house price prediction, can you tell me what is the task? Obviously, the task is to predict the prices of the houses on the basis of features of the houses, like size of the house, age of the house, number of bedrooms of the house, location of the house, and so on. Now, what is performance measure in case of house price prediction? The performance measure is how close the predicted prices are to the actual prices. And what is experience? Experience means the data from which the machine learning model learns the patterns, features, and relationship. So in this case, what is the experience or the data? The data will be the collection of several houses along with the labeled prices, so that the machine learning model can understand the relationships between the house features and the house prices. In this way, we have understood the first step, that is problem definition. Now we will move forward towards the second step of the machine learning pipeline, that is data collection. It is the process of gathering the raw experience E or data required for the machine learning model to learn. So I have just explained you that machine learning model learns patterns and features from data. Now, data collection is the process of collecting or gathering that data so that the machine learning model can learn patterns and features from that data. Raw experience is same thing as data. I have just explained you under the TPE framework that experience E is nothing but the data required by the machine learning model to learn patterns and features. So this is data collection. For example, a house price prediction dataset looks like this. In this dataset, you can see there are multiple features of the houses like house ID, size of the house, bedrooms of the house, location of the house, age of the house, is garage present in the house or not, and finally, we also have the label that is price USD. This is to be predicted by the machine learning model. So these are the features: house ID, size SQFT, bedrooms, location, age, years, and garage are the features of the houses. And price USD is the target variable or the label of the house price prediction system. Now, as I have just explained you, that data collection is the gathering of raw data. That means this is the raw data that we have collected. So this data needs not to be perfect. It can contain various errors. Like you can see, the size SQFT, that is the size of the house, here is 0 and here it is negative, which is not possible. Size of the house can never be 0 or negative. Also, you can see the age of the house is negative, which is also impossible. Here you can see we have multiple missing values also. There are 2 missing values in bedrooms field and there is also 1 missing value in the price USD field. Also, if you carefully observe, in the field garage, there is an inconsistency in the format. As you can see, this yes contains all the uppercase letters. This no contains all the uppercase letters. But the other yes and no are in proper title case. So this is an unformatted text. Also, you can see these 2 rows are duplicate rows, which is also an example of error. That means the data set that we usually collect is not perfect. We need to perform the fixing of these errors in the next step of machine learning pipeline, that is basic data cleaning. Now we will understand more about data collection. Data should be relevant to the problem. That means the data that we are collecting should be relevant to the problem statement. If the problem is to predict the prices of the houses, then data set should look like this, which only contains the features of the houses and the label that needs to be predicted by the machine learning model. Next point, data should contain features and labels in case of supervised learning. Like in this example, you can see the house price prediction dataset contains features of the houses along with the label that needs to be predicted by the machine learning model. So the data that we collect should contain the features along with the target variables, that is labels. Features are the input variables and label is the output variable that needs to be predicted by the model. Next point, data can come from databases, surveys, sensors, websites, etc., which means that data that we collect can come from multiple sources like companies' databases, surveys like Google Forms, sensors, and data can even be extracted from websites using a technique known as web scraping. Next point, the quality and quantity of data affect models' performance. If the quality of data is bad, the model's performance will be bad. And also, if the quantity of data is not sufficient, machine learning model cannot learn that data. That is why it will also affect the model's performance. It is to be noted that machine learning model cannot learn from incomplete or less data. That is why the quality and quantity of data are very important factors to check while data collection. In this way, we have understood the second step of the machine learning pipeline also, that is data collection. Now it's time for practical implementation. So now we will go to my computer system and there I will show you a data set of house price prediction system that I have collected. We will upload that data set onto Google Colab and we will perform some operations on that data to analyze that data. So now we are on my computer system and here you can see I have one Excel file, house price dataset. Now we need to click this file so that we can open this file. This is the house price data that I have collected and you can see house ID, size SQFT, bedrooms, location, age years, garage. These all are the features of the houses and this price USD is the label or target variable. You also have to see that there are total 125 rows in this particular data set, out of which the first row is the header row. That means this is the header row, which means there are total 124 houses information in this particular data set. Now we need to upload this particular file or the house price data set in Google Colab so that we can analyze our data. Google Colab is a platform by Google on which we can run the Python codes. Now we will upload this file on Google Colab. For that, first I need to close this file. So I will close this file here. Now I will open the Google Colab. I have already opened the Google Colab and you can also open the Google Colab through any web browser. Now here you can see this is the code editor of the Google Colab and this is the file section. This file section is accessible by this file icon button. Now here in this file section, we need to upload the data set that I have collected, the house price data set. So here I have to right click and I need to click the upload button. After that, I will select this house price data set and I will click open. And you can see house price dataset.xlsx, which means it is an Excel file, is uploaded in the file section. Now we have to analyze this particular data set using Google Colab. This is the first cell of the Google Colab from which we will start coding. Now, the library that is used for data analysis in Python is pandas. Yes, pandas library in Python is used for data analysis and we need to analyze the data, so we also have to use the pandas library. Now, how to import pandas library in our Google Colab? We need to write the import keyword. After that, we need to write pandas because we want to import pandas library. Now, from this line, pandas library will be imported in our Google Colab. But I cannot write pandas every time. So I will give pandas a shorter name. So I will write as PD, which means I have given this pandas a shorter name PD. Whenever I want to use pandas, I will write PD. Now I have to run this cell. To run this cell, you need to click this particular icon. This icon you have to click to run this particular cell. Or you can also press Shift plus Enter to execute this cell. When I will click this run button, you can see here is a tick mark, which means this cell is successfully executed. Now, we have to create a new cell. For that, we will click this code button and this is the second cell. Now, the pandas library is imported into the Google Colab. Now we need to import this house price dataset here in our code. For importing this dataset in our code, we need to write pd.read_excel. Now pd.read_excel means that read_excel is a function inside pandas library. That is why I have written pd.readExcel, because this function needs to read the Excel file that we have here. Now, since this is a function, I need to have the parenthesis over here. And inside the parenthesis, I will write the name of the file. So what is the name of the file? house_price_dataset.xlsx. So in this parenthesis, within the inverted commas, I need to write the exact name, that is house_price_dataset price underscore data set dot xlsx. Make sure that you don't make any spelling mistake while writing the name of the file. Now, this line will read the entire house price dataset. Now, after reading the entire house price dataset, we need to store it in a particular variable. That is why here I will create a variable named as df, and I will store this entire dataset into this particular variable, that is df. Now, why I have named the variable as df? Because this is a data frame variable. Data frame means the collection of rows and columns, and this variable represents a data frame. That is why I have named this variable as df. Now, again we have to execute this particular cell. For executing this, I need to click this button, and this cell is also successfully executed, marked by this tick symbol. Now we will create one more cell by clicking this code button. This is the third cell. So now we will see what all has been imported from our house price dataset here in the code. For that, I will write df.head. And since this is also a function, that is why I will use parenthesis. Now let's understand the meaning of df.head. It means the head function is applied over the data frame df. This is the data frame df, and I have applied head function over this data frame df. Head function by default returns the top 5 rows from our dataset. So when we will execute this particular cell, we will get the top 5 rows from our dataset. 0, 1, 2, 3, 4. These are the top 5 rows from our dataset. Now, since our dataset has been successfully imported, we will close this file section. So here I will click this cross button, and now you can see this is the dataset that we have imported from our file section into this code. Now you can make certain changes in this particular line. Like if you need to import total 10 rows from the top, you can write 10 inside the parenthesis. And when you will execute this particular line, this time you will get total 10 rows from the beginning from the dataset. Now you can also write tail instead of head. And guess what tail returns? df.tail 10 will return total 10 rows from the bottom of the dataset. So these are the 10 rows from the bottom of the dataset. And if we remove this 10 from here, and then we will execute this cell, we will get by default 5 rows from the bottom of the dataset. So this was the functioning of head and tail function applied over the data frame df. Now we will further analyze this dataset. So now I am going to apply a property known as df.shape. Since this is a property and not a function, that is why I will not write parentheses after this. Now let's understand what is the meaning of df.shape. It means this property will return the shape of our data frame df. Shape means it will return the total number of rows and columns from our dataset. How many rows and columns were present in our dataset? There are 124 rows and 7 columns in our dataset. Let's execute this cell. And see, we are getting the same results. 124 rows and 7 columns. 124, 7 means there are total 124 rows and 7 columns in our dataset. Now let's apply the next property. For that, we need to create one more cell. This time I am applying the property df.columns. Now guess, what df.columns will return? Obviously, df.columns will return the names of all the columns. So when I will execute this cell, we can see that here we are getting the names of all the columns present in our dataset. House ID, size SQFT, bedrooms, location, age years, garage, and price USD. These are all the columns present in our dataset. Now I am going to apply one function over the data frame df. And the name of the function is df.info. Since this is a function, I will use parenthesis. Now when I will click execute, you can see df.info function gives the overall information about our dataset. This is the entire information of our dataset. Range index 124 entries 0 to 123. It means there are total 124 entries, or we can say 124 rows present in our dataset from index number 0 to index number 123. Next line, data columns, total 7 columns, which means there are total 7 columns inside our dataset. These are the names of the columns from index number 0 to index number 6, which means there are total 7 columns. These are the names of the columns: house ID, size SQFT, bedrooms, location, age years, garage, and price USD. Non-null count. What is non-null count? It means the total number of entries present in that particular column. In the column house ID, there are total 124 entries, which means there is no missing value. In the column size SQFT, there are 123 entries, which means there is one missing value. Similarly, in the column bedrooms, there are 122 entries, which means 2 entries are missing in this column. So in this way, we are also getting the count of missing values in our dataset. Now let's understand what is this D type. D type means data type of that particular column. The data type of house ID is object, because house ID is basically string, and string in Python is an object. That is why the data type of house ID is object. Similarly, the data type of size SQFT is float, which are basically decimal numbers. The data type of bedrooms is again float. The data type of location is again object because it is also a string. The data type of age of the house is integer. The data type of garage is again object. The data type of price USD is float, which means total 3 columns are having float data type, only 1 column is having integer data type, and 3 columns are having object data type. In this way, we have understood the implementation of the function df.info, which gives us information about our dataset. So in this way, we are done with the practical demonstration. I have shown you a house price dataset that I have collected. We have uploaded that dataset in Google Colab. Then we have created a data frame. We have applied many functions and properties over that data frame to analyze our data. This process is known as exploratory data analysis. Now let's get back to our presentation. In this way, we have understood the theoretical as well as the practical aspects of the initial 2 steps of machine learning pipeline. And in this way, we are done with our topic, problem definition and data collection. So this was all from my side for this lecture. Thank you, and I'll see you in the next one.